So, good evening, everyone. My voice is audible
Yes.
and screen. Kindly confirm both the things so I start. So, good evening, everyone. Till now, in last 4 days, we have completed the foundation of road design in Civil 3D. We learned point creation and management, surface creation, existing ground surface, then alignment, road center line design, then profile. In profile, we saw vertical design, then design criteria and standards. So basically, we have defined where the road will go and at what elevation. Today is the most important day because now we will convert that design into actual 3D model. So today we will show the road model, how our road work on a real site. Then we show the cross sections of road. Then we check the quantities, and at last we show drawings, how we send our drawings to the client or how we export our drawings and how we made these drawings. So this is what the real design engineer do in projects. So before we starting tool, first understand the complete workflow. So you have to understand the total workflow in different 8 steps. What we are going to do today. The first, the alignment, horizontal design. As you saw here on the screen that we have drawn an alignment here. Then we create that vertical profile. This is a profile view and it is a vertical design of road section. This road section and this road section. Okay. Then assembly. So road cross section design. So for after assembly, we are going to show the corridor. So on this alignment, if I want to create an corridor, so basic requirement is assembly. So today we show assembly, which is road cross section. Then we go for the corridor. When you create the corridor, you can see your road as a working model. Then we check how to assign the sample line, which is the cut section. It is used for the section views, which we called as a cross sections. Here you can see in a profile and section view, all these things are given: sample line and section views. Then we go for the quantity takeoff, and then at last earthwork calculations, and then drawing output in the form of sheets. So now today we are connecting everything together. So today will be a interesting lecture. So let's start with the assembly first. Now the question is, we design center line and profile here, but what is the actual shape of road? How you see the road? So this is just our center line of the road. As when we selected the alignment from here and create a new alignment, uh, I hope you knew that we set as a central line to this line. See, so they now we create a shape for this alignment line, and we called it as an assembly. So basically, assembly is a cross section of road. For you, here I see. This is a basic, cross section of a road. So here you can see the right of way, which is the two end of our cross section. Then there is a carriage way where our vehicle is going. Then we have two shoulder, left side and right side. So the area from starting from the shoulder and end to the shoulder, it is known as a roadway. So this is carriageway, roadway, and then right of way. Right of way cover all the things apart the shoulder. Then it will be curb. Then it will be a margin area. Then it will be cut and fill slope area, drain area. All that things are covered in a right of way. So whenever you are working on a real project, you have to take care that you are not going outward this right of way, because this is your boundary. So whatever the work you have to do, you have to keep it under the right of way. And whatever the design you have for the carriageway, shoulder, and this curb and drain, so as per the standard, you have to set all that things. So today we are learning this whole thing. I hope you understand through this image. Now, let's create this assembly here in our Civil 3D. See, to in assembly, uh, we take three, four things. Like first is a lane width. Uh, in an image, you can see this the lane width here. So first we set this lane width. Then we set shoulder. Then we give the slope to the shoulder. Then we provide a curve too, and at last we give the side slope. Okay, and then for connect this cross section with the ground, we give the side slope. Sorry, we give um, catchment. It is not basically catchment. I will show you here in a Civil 3D. So first, we use this subassembly like a small parts, and we combine this all parts. It is called an assembly. So when it is all together, we call it as an assembly, and when it is in a single part, we call it as an subassembly. Uh, let's start it here. You can see, if you put your cursor here, it will show an assembly here in a create design ribbon bar. In a ribbon bar, when you come here in a create design, you can see your sub assembly part here. If you click here, you see create assembly, create assembly. So we are not using this. We are using this create assembly. As you select a create assembly once, see, again it will give us a one dialog box. In this dialog box, the process is same. The name, as we set the name as our assembly number 1, or then in description you can set all the description that what you want to include in this assembly. If you send this design file, or if you send this all the file to the client or the contractor, so for the better understanding, you can give the description here. Then assembly type. Here we have the undivided crown road, undivided planar road, undivided. What is this road? We see later, and we can use this for a railway also. So now I keep it as a other, so we can use this assembly for any type of work. Now, as we have a style in all, in points, in surface, in alignment, so the same way we have a style. Also, we have a style here. So you can keep any style, or you can make your new. You can edit your style. So whatever you want to do, the workflow is same. Here you can give the name. Here you can set your marker style, display style, and all that things. Now the code set here. See, in assembly, this code set is not the design code set type. Okay, here three things are there you have to consider: link, shape, and code. I will show you this assembly in subassembly composer too, so you understand all the things. And this is the layer. Now, if you click OK, they will ask you to specify a baseline location. So here in this area somewhere, I can you click here. So as you click here, you can show a baseline here. See, understand this baseline first. This is a node point, 0 point, where your assembly will start. This is your right side and this is your left side. So whenever you put your lane, your shoulder, you have to select the side here. This round is the code. So you have to put all that things on that particular code, so your assembly will define as per you want. Now, how to set that all things here? So to for check where is your solder, what is your solder, where is your lane, what is your curb. For all that, you have to go here in a palette bar. Here in a palette, you see here first one tool palette, or you can press Control 3 for open this tool palette. If you click on this tool palette, see one tool palette is open here. Here now understand first what is this. If you are going a basics, so the lane is there, basic lane transition. So if you create one road and you want to stretch the road, so at that time you select this as your lane. So this transition lane is whatever your lane you give the width, this lane is go along with the lead width. So many type of basic lane is here, shoulder is here, curb is here, curb and gutter, side slope and cut ditch. So the last part that I want to show is this one, this area. So this one is this. You can provide this. It is so here in a we have a different folder here. So in a lane, you see the particular lane, all the lanes, different type of lane. See, this is the crowd lane. What is the crowd lane? It means from the center there are slope two side. In a uncrowd lane, you can flat surface. So this type, different type of lane Civil 3D provided. Then here custom, you can set your own sub assembly too. You can create your sub assembly with the use of Civil 3D software itself, and also Civil 3D give you the sub assembly composer. So with the help of this sub assembly composer, you can as per your requirement you can draw your assembly here and move it to the Civil 3D. Remember, the file type whenever you save this thing here, the file type is .pkt. So you have to remember this file type also when you work in a sub assembly composer. See, then different type of solder is there, then different type of curve is there, different type of daylight is there. If you right click here, so all the things you can show here. If you want to show the bridges, you can select the bridge, type of bridge is there. Or if you want to import this as I make the new folder as this is the new rehab sub assemblies. Then sometime when you right click here, you can create your own palette. So these all are palettes. You can create your own palette. As I give the name day 5. So this is my new palette. If I want to add any assembly here in a format of .pkt, right click here and you can import the sub assembly from here. If you import the sub assembly, they will ask you the source file, and then in your folder wherever it is, you can I have this, I created this assembly, I can open it. Okay, so the layer is here. If you want to rename the layer, you can give it day 5. So this type company works. They create their own assemblies and they put their assembly here. Now let's start with our lanes, basic lanes. As you saw, different type of lane here. Let's start with this lane super elevation AOR. If we select this, automatically we have the properties of this lane. When you select any of this, or in this palette any of the sub part, as you select that part, you show properties here. In the property, you can change all the things. What is the lane slope, what is the lane width, uh, See, in advanced option, you see all that parameter. Then what is the side? So right side. So for this one, if I place it here, it will show left side. If not shown left side, then you have to make it a left side. Then the width of the road, then the slope of the road. Then it have 1, 2, 3, and 4 layer, and all that layer, the thickness of all that layer provided here. Super elevation, there is no super elevation they provide. So all that thing you can change from here. If you click here, I want the width as 3 meter, you can select 3 and enter. Now slope is okay. Now what I do, I have one square here on the screen, which is a marker point. If I want to place this lane super elevation here, if I click here in this area, so your lane super elevation you can see here. Now see, we have all the layer here, a top layer, then the second layer, subgrade layer, grade layer, base, sub base, all that layer provided here. But this is a auto sub assembly created by the Civil 3D itself. If you use this, you can manage all your data with the help of the property. If you select this assembly, you see here in a ribbon bar, you check this tab. As I previously said, in Civil 3D, whatever you select and the tool is and the content is from the Civil 3D itself. If you click here, it will show you this bar. Here there are two types: assembly properties and sub assembly properties. See, understand these two things. When you select assembly property, it means it work on whole assembly. And when you select the sub assembly property, it means it will work on for this sub assembly only, the lane assembly. So I click on the sub assembly property. So here, if you want to provide some name, you can give the name. Parameters, the parameter in property we checked, the same parameter you can see here. Okay. Then the codes. In the codes, there are three things: link, point, and shape. These three things. If you generate any assembly, these three things are mandatory to insert. See, in the link, they provided all the link for all the layer. In the point, they provided all the point. And in the shape, they provide all the shape for, there are 4 layer in this sub assembly. So all 4 layer shapes are provided here. Now, if we select this and we go in assembly property, in assembly property, as you know that we give the name as assembly member 1. You can set style from here also. In a construction, you see in a baseline we have a right lane imported here. So you see all the workflow. First of all, we have a baseline. You can see the baseline. Then this is the right side, and at the right side we gave a lane. So you see the workflow here. If you want to change anything, you can change it from here also. You can change the volume. If you want to use this layer or not, you can keep it, or you can so this all part you can select, or you can work with this whole part from here also. So this is the basic thing to understand before starting the sub assembly part. See, once we provide this lane, remember, as we click on the sub assembly property, in a parameter we change our width as a 3 meter, our slope is -2%. So we have to remember these two things. So throughout the work we use all these two value. So for a betterment, because every time Civil 3D gives a different values property, so we make it this to make our flow in a better way. So now let's add the solder. As you shown in figure, first we give this lane. Now we are providing this solder. So we can select any solder from here. Now I am taking the standard solder only. But when you practice this thing, you make a different type of assembly with the help of the IS code, or you can check on the internet type of sub-assembly, cross section of sub-assembly. So as per the cross section you can create here. So if you want to add this solder here, you have to select on this top only. So in this lane, in this top, this round part, you have to click here on this round part. As you click on this round part, the solder itself attached automatically with this lane. Okay, the same way as we click on the solder, the properties of this solder are here. See, here you saw all the detail of the solder. The right side solder width is 2.400. If you want to keep the solder width as um, 1 meter, you can set it. No superelevation, slope minus 2%. Daylight is also you can set as 2. Then all that things done. Now as you see, now we select this solder and go in a sub-assembly property. So if you want to give the name, you can rename this here. In a parameter, you can see our right side solder width is 2.400. Then our super elevation we not give solder slope, we change it to 2 meter. As we if you want to change this as one, you can select as one, and the daylight slope we can give as a 2. And rest we are not changing anything. And then if see here, if I do apply, so the width is automatically changed. Okay, so remember all the value they we are given. The solder width is 1 meter now. Now let's add a curve. I hope you know all that definition. What is the lane, what is the work of solder, what is the work of curve, what is the work of median. So if you want to provide the median, you can provide the median here. So if you provide the median here, then we go for the left side. So median is in center. So uh, the right side of the median there is one road, and left side of the median there is one road. So you can adjust this also. Then we go for the curves. Take this curve and see. As I said, you have to put it on the top only. So even we have a different layer here, we use this top only. So as we click here, you saw our curve is created. Now the next thing I want to show, see, now we go here for this curve and check the sub-assembly property for this curve. You can change the name, the parameter, you see slope and all that things. So we set all that things first, we check all that things, then we go further. Now see, if I select this lane, so there is some commands here. This is the copy, move and mirror. This is not the command we used previously. This is not the copy as we used previously. This is not move. This is not mirror as we use in a mirror command when we are in a 2D view. So how this works? If you want to set all these thing here, so again and again you don't have to select and click all the things. What you do, you just simply select all these things. Okay, and then you click the mirror command here. A marker point is there, and they are asking us to select the assembly where you want to mirror. Select the baseline. So I select this baseline. So as I select the baseline, so all things is copied here on the left side. Now check, if I select the left side lane and go for the sub assembly properties, in a parameter you can see the side is left here. So now all set. Now I just create this basic assembly here. I will show you one thing here in a sub-assembly composer. See, when you create this sub-assembly composer, there is a point first you see here. if I am talking about this one lane only the first layer. So you can what you see here, you see the point P1, P3, and the point P2, P4, and P5. So the first one is the point. So you saw three things in that properties: point, link, and shape. So the points that we set first, then this is the link. The link is created between 2 points. So if I want to join these 2 points, I have to create a link. And the shape is given here in a center. Once this close boundary is created for the first pave road, so we give the shape here. As you select the P1 point, see, as you select the P1 point, here the P1 point is selected in the preview mode. And in properties mode, we give the point code as a name as a crown. So when you select the first point, if you want to see this point, uh, we can show the name crown. Remember this name. In a civil 3D, we go further, we show this type of name, so you understand where this name come from. This origin and all the this is the node point, so there is nothing here. If you click here on the link, so which link we use, you can see here in a flow chart. And what we provided for the link, you can see here all the things. So here you can see the codes are here, points are here, and link are here. Link is there. Now see the value of delta y. As a link is here in a y-axis, so we give the delta y value as a minus pave 1 thick. And here is the all the target parameter we have to create. See the pave 1 thing. Pave 1 thickness is 0.1 right now. If I change the thickness here as a 0.2 and set as enter, automatically this width is changed. So I put it as a 0.1 again. So if you fit the screen, then automatically this will set. So this is the sub-assembly composure. It is very important thing to know, because Civil 3D sub-assembly composure is itself a very lengthy, composing software. So to understand it, you have to, attend at least 15 to 20 lectures of this. Then you understand these things and you create your normal assemblies, daylights, embankment, then culverts, all that things we created with these things. So once you created it and imported it to the Civil 3D, then you cannot edit anything. So whatever you create, you have to take care all these things. I saw this workspace because when you are in a Civil 3D and you work with this, you understand that what is this and where these things are coming from. Okay, now we have a sub assembly here. Now the next thing after the sub assembly is corridor modeling. See, before start the corridor, I will explain you what is the corridor. So corridor is the most powerful tool in a Civil 3D. See, corridor is created with the help of the number one alignment, the number two profile, and number three assembly. To create the corridor, we have three things: alignment, profile, and assembly. That's why we create alignment first, then second profile, and now third assembly. So now we have three things, so we can create our corridor. Corridor, it creates a full 3D road model. Then we can check the cut fill condition with the help of this corridor. And for the quantity calculation, also this corridor is useful. So when we create the corridor, we have to select the alignment, we have to select the profile, and we have to select the assembly. These three things is mandatory. So software automatically generates road along the entire alignment. So I hope you understand this corridor. So as we work with the corridor, you understand the things what I told you right now. Suppose our road length is 1 kilometer. Assume that our road length is 1 kilometer, and assembly will repeat at every station, like 10 meter interval, 10 meter of interval. So that's how full road is created. See, when we apply this assembly on this road with the help of this profile, so this assembly, repeat it every 10-meter interval. The first interval, second, third, fourth. I will show you the lines, and that line will be the assembly. Okay. Important things in a corridor. Three things are there: the baseline, the region, and the target. I will show you all the things, but before we start all the things, I want to make sure that you know all the names. When we take the name at that time, you understand what is this. So baseline is this. So if this is a baseline is what? Baseline is the thing where our work starts. Region is, if I select this baseline and create a full corridor here, so this will be my region. And the target is, if I want to set this corridor at some distance, I have to set the target. Okay, this is the thing. I will cover it, but understand this all the terms. So now we have assembly and profile. Now we go for the corridor. So for creating corridor, first of all, you know that where is the corridor in a here design, create design. We have a corridor here. See below the profile section. As you click on the corridor, you have one option named corridor. When you select the corridor, again you have one dialog box. Here in this dialog box, we have to give a name. See, naming is very important here. We give the name is a corridor 1. As I show you here, if I set a number 1, then it will automatically take the corridor number 1, but I will put it as a name corridor number 1. Or you can take a name is a road number 1 for a better understanding. We set is this is our road number 1, or road corridor number 1. Description is you all know, corridor style is there, layer is there. See, for making a corridor, you need two things. Either you have alignment or profile, alignment and profile, both is important. Either you have feature line. If you have feature line, you can create a corridor based on the feature line. But if you don't have a feature line, then you must have these two things, alignment and profile. So I have alignment and I have profile, so I click on this. Then in alignment, I have road 1 and road 2. So I'm doing this for our road 1, so I create select on a road 1. And this is the option. We can select the road 1 from the drawing. As I click here, I select this alignment. As I select, the road 1 is automatically selected. Then same as a profile, as we have a road 1 surface profile and a road 1 design profile. So I tick it as a ABC surface 1. Okay. Now we have assembly, and we give the assembly as assembly number 1. So I select that assembly. Then if different company have their own template, so if there is a template, you can select the template from here. If there is no template, it is not an issue. Target surface, we have to set the target where I want to put my corridor. So we set the target ABC as our surface name, and we click here as a set baseline and region parameter. Take all these things properly. If you want to confirm this thing, then you go and click OK here. As you select OK button, you see two things. See, BL is a baseline and RG is the region. So corridor created with the help of these two things, baseline and region. See, in this region, you can see all the things, the horizontal baseline. This is our vertical baseline. This is our assemblies. This is our starting station, end station. Frequencies, you can set your frequency like here in a horizontal baseline. The frequency is set as every 20 meter of interval. If you want more focused area, you can set it as a 10 meter of interval. So at every place, for a curve increment, I use the 10 meter. For a spiral also, I use 10 for baseline. So I set all this as a 10 meter, and then I select OK here, and now all set. Now I say OK. So as I say OK, it will say rebuild the corridor. So yes, I want to rebuild this corridor. As I rebuild the corridor, you can see our corridor is created. This is our station number 0, and this is our station number 519. Okay, so the curve is created. See, this is assembly. The assembly we create here, this assembly, they take it as different intervals. See, so I hope you understand till now. I select this corridor, okay, and go in a object viewer. So you can see your corridor created properly. You can see your whole corridor created properly. Intentionally, I give one curve here because at last we calculate the super elevation also. So I will show you all the detailed things here. Don't worry about it. So now I hope you understand. So what we do now, see, intentionally I didn't give a daylight here. Is right now our road have no target. So you see our this is our center line of alignment. This is our road length 3 meter. This is our shoulder 1 meter. Then we set a curve here, and this, see, if I click here, it will show the, when we click on the line, it will show us what is this at last in a point codes back curve. As I said here, it is a EPS PAV 2. Then I see here ETW. ETW means this is the end of our PAV 1. Then our PAV 2 is start. So EPS, then the third PAV line EPS PAV 1, then our last band PAV 2, then our base, then this dotted line. See this blue dotted line. If you select this dotted line, it is the our curve return parameter. So this is our curve we provided, and this is our curve end. So till we create this, now what I do, I give the daylight also. Why daylight? Because when you have the daylight, so daylight what do? Daylight is used for the cut and fill criteria. As I provide the daylight here, so what daylight do? Daylight is start with this corridor, and the end of the daylight is this surface. So on this surface, our from where our road is passed, so daylight show us that what is the cutting area and what is the filling area. See, first of all, I select this corridor, and I go for the drive. So if you select the corridor and you go here in analyze tab, you can show a drive mode here. If you select on the drive mode, it will ask you to select the feature line. See, I select this feature line. See, the crown is here. I will show you the crown in sub-assembly composure. So crown is the center part. I will set the crown. I want to show my road from the crown and set as OK. You can see your corridor is on the surface, and there is no cut fill here. So your corridor is some exactly on the surface, and there is no cut and fill. Why? Because we create our corridor, but we don't give the corridor the daylight to show that if they are passing through the up surface, then we have to cut. So I have to give the criteria to this. So I close this again, and again I select my assembly. And what I do here, I go here in a daylight, or you can from the custom shoulder, we all that things, we go for the daylight here. You can set any daylight here. You, if you go here in a basic, so all the basic things are also here. So I select this basic side slope cut ditch. As I select this, as we have to select on the here is created. So what this daylight do? The first corner is connected with the curb, and the second corner is connected with the surface. Okay. So same way, if you provide this daylight here, so you can provide it same way. Or if you want to mirror the daylight, so you can. But I need. So for that, what I want to move this sub assembly here. So as I select here, our daylight is moved from here to here. Okay. So now your full assembly is created. But see, here on the corridor section, you can't see anything here. So we select our corridor, and here you can see the rebuild corridor. As you rebuild the corridor and click OK button.
Sorry, sir. I think you have some issue with the internet.
Okay, sorry. Sorry for the inconvenience. Give me only 1 minute.
Yeah, hello, but you need to repeat it from at least 2 minutes before session because the screen has been still for almost
No
like
worry,
two,
no
3
worry,
minutes
no
now.
worry, no worry, no worry, no worry. Don't worry, I will repeat it. I hope now it is visible.
Yes,
Okay. Now is it visible now?
yes, it is visible now.
Okay, done. So what I do? I just undo the things. I just undo all the things. I undo all the things, and then I do it a little fast so you can understand. If you, I don't know from where you left the things. See, again we here we have this assembly, and still we are not provide the corridor. See, what we do, we provide this basin here and here. Done. Now again we create our corridor. So for the corridor, you have to go here in a corridor option, and then in the corridor you give the name. I will provide the name as corridor number 1. Then alignment and feature line select. Then select the assembly number 1 as I created. Then we select the target as a surface as a target, and then set OK. As I set OK, I have a baseline and I have a region. These two things, and I click apply and reveal the corridor and OK. See, now As a previous, we don't give the daylight. We didn't provide the daylight. We just provide a curb till the curb and create a corridor. So at that time we don't have this thing. See, this red area is showing as a cut and the green area showing as a fill area. See, if I put my cursor here, you can see at the bottom of this pop-up, top datum daylight cut link. Okay, so now I select my corridor and again I go for the drive. I have to select our feature line as a center line of this alignment, and then I have to select the from where you want to see your road. So always I see from the crown, set as a OK. As I set OK, now you see this is our lane. This is our center line. This is our shoulders. Here you can see the curve, and at last as we play we see the curtain free area also. See this menu here on a top, you can adjust the view from the here. If you want to set your speed, if I want to see at the speed of 50 or 49 kilometer, I can set the speed. If I want to see in a different view, I can see in a different view. If you select any view, you can see the view here. If I want to set our target, so by clicking this you can set the target. See, as I select the target, you can see the difference in the here in the preview mode. This is the eye side, from where you want to see, from the top, from the side, from this meter. So as you set the site, you can see how you see your alignment. Okay, your corridor. Now as I say play to it, now your corridor is working. See the beauty of the Civil 3D software. See now you see here all your lanes and properly divided. See now this area you see here the filling and cutting of the surface here. See again you see here the fill and cut, and see the cow part is over. Now this is a little up and down create. See, so now we understand that. Let's off this. Now we create our corridor. For creating our corridor, what we need the assembly profile and alignment. Okay, once we create the corridor, we can drive through it and check how our corridor is created. It is smooth or not. If you want to give the more speed, you can give the more speed to the corridor. You can check. Once you go through your corridor, you drive through the corridor, you automatically understand this road is okay or not. Okay, once you create the good experience, is you understand that how this all things works. I hope till corridor you understand all the things. Now what I do, let's we go for the sample line. Is I want to set a cross section view for this corridor. I want to see how our corridor is look at different section. So for to check this corridor from the different section, I have to provide a sample line here first. So sample line is used to cut the road at the regular interval. Hello, I think someone mic is on. Please turn off your mic. Some voice is there. If your mic is on, please turn off it. And any one of you, please tell me again that my sound and my video both are visible. Please confirm me so I go ahead. Hello. Hello.
We can hear you and we can see the screen.
Okay, okay. Thank you. No one is, saying anything. So I think I lost or what again? So don't worry. Let's go for the sample line. Now, sample line is used to cut the road at regular intervals, like slicing the road at every 10 meter or 20 meter, whatever the distance you require. So create a sample line. We have to create the sample line first, then we create a sample line group, then we give the different interval of that sample line, then we select the surface and corridor to understand our cross section views. For example, if the road length is 1000 meter and I give the total 20 meter of interval, then total cross sections that created is 50. So you have this little calculation in your mind. So you can visualize this properly. So let's create the sample line first. Then I make you understand about the cross section. See, to create the sample line, what you have to do, you go here, profile and section view, or you can make it from here also. See, here there is a tab named section. So if you click on the section, you see a create sample line tab. If you click on this tab, so it will ask me select an alignment. So I have to select my this alignment because I create a corridor throughout the alignment. So what I have to do, I just select my this corridor, and this is the here this is our icon. I can click on this icon and I take back our corridor a little one, so I can see my alignment here. See, now you see the alignment. Now again, I go to here in a section view, create a sample line. Then I have to select the alignment. As I select the alignment, the dialog box we show here. As you can set the name here, SL means sample line, and see the starting number is 1, so not an issue. So it will create SL collection 1. Now the sample line style is there, label style is there. So all that things, once you when I teach you the point, that's why I take a long time in a point and surface. So if once you understand all these things, you can do it for any points. See, now in you are in a sample line. If you understand the editing the points and point style and label style, you can easily do this thing also. So it is not a big task. That's why I took a long time in that 2 sessions. Now alignment is road 1, that is okay. Now we have 2 things, the surface and the corridor. So I have make sure that I have check mark here. Then the style for the surface, I use the ground style, and the corridor the basic style, and the length, and most important thing, the mode. Make sure that your mode is dynamic. So as you change anything here, automatically all the thing will change as per the changes. Now I select OK. As I select OK, as we create the alignment, we have a pop-up bar. Now as we set the sample line, we have this pop-up bar. Now you can set the name of your if you have any templates, you can set your template from here. You can set the name from here. Now the most important part is here. This is our sample line where we worked on. If we click here, you can see create sample line in group. But before creating the sample line, we come here in this option, the sample line creation method. So first of all, we have to create the sample line. So for that, there is lots of points at a station. If I click at a station, so at any particular station only, I create a sample line. If you from corridor station, so the same way at 1 or 2 station you can create. For each station you have to click. You can pick a point from the screen. You can select any existing polyline. On that polyline you can create a this thing. So method is same for all that things. as we select the generally we use this by range of station method. As you select on by range of station, the pop-up bar is there. Here you can see the general your road alignment which you used. Station range. So we started from the station 0 to our end of the station. As I slightly move my corridor from here to here, so our last station is 0 point plus 519, but I move my corridor, so it will show station 1518.61. So it is not an issue. If you select this here, it will automatically come there. The left swat width, it means if I click if I make a simple line here, so from the left side, what is the width you want from the center to here. So you 20 meter is enough. Then the right side width, then simple increment. So if you want to increase that things, you can increase it from here for the curves and for the tangent and for the spiral. You can keep it 25, 30, whatever the length you want, you can keep it here. And if you want any particular station or for particular geometry, you can set as a true, and you go for that. But right now we are not using any of this because this is a uh, you know uh, less usable in a complex model. We use all these things, but right now we have to understand the workflow. So I show you this all things. Now we click OK. As we click OK, you show your sample line here. If you want to change the style, you can change the style. Now what they ask me, specify station along baseline. So I want to set the station as my zero station is here at somewhere. So I can click here, or I can say 0 and then select enter. Okay, and the width okay, done. Width is okay. So our baseline is created. See, our sample line is created. As our sample line is created, I what I have to do. See, this is our sample line created. So every 20 meter of chainage, we create our sample line. See, 480, 500, 460, 440. So at this particular stage, we see our cross section. Okay, as you select the sample line, you can see, if you select this point, the base point is not move, it is fixed. You can move this if you want to set something and you want to shift this sample line, you can shift it with the help of this button. If you select here, you can increase or decrease your sample line with the help of this button. Then if you select one sample line, there is two things again: a group property and a sample line property for a single sample line property. If you work for the whole group, you can go for a group, and if you work with a single line, you can click it here. If I click in a group property, you can see all the sample line is selected, what is the chainage is there. If I select all things, if I select here and press the shift button and select the last one, and then if you want an increment of 10 and set enter, so the left offset as I apply, see the left offset, it will go at the 10 meter of increment instead of 20. So again I give 20 here at a left side. See, on a left side you can see your 20 meter come again. For a section view, we have the surface profile and the corridor profile. Then this is used for when we take the material and quantity takeoff. So now we are not doing anything, and we just click OK. Now again we go for the sample line properties. So which station I selected, it will show the name here. You can select the style from here, or you can edit the style, or you can create your new style from here. In a sample line data, you can see you have selected the sample line number 21, and the group name, the road, and the station, all the things you can see here. In a section, what you see the surface and the corridor. Okay, if you want to set the style, you can change it, also change it from here. Make sure it is dynamic. Then in a section view, still we are not creating any section view, so there is nothing here. Now edit sample line. If we select the edit sample line, so you can edit the sample line from here, but right now we are not selecting any, so there is nothing. But as I select and edit the sample line, we can edit it again from the here. So with the help of this by range of station, we create the sample line. Then we go for here and create a sample line group. So as this is our tick mark, then the group is automatically created when we set our by range of station. If you want to edit this group, if you want to delete this group, if you want to select the group from the drawing, so you can do it from here also, you can do it from here also. Okay, if you click here, you can see the properties also here, but right now we are not providing any data. Now as I select this sample line, so all the detail of that sample line is come here. Okay, if you go for the next vertex, so the all part detail of this come here. So with the help of this sample line tools box, you can modify all the sample line. Now as our sample line is created, now we go for our section view, cross section view. Now cross section view, as you know, here while creating this sample line, we take two things. The first is existing road, and second is proposed road. So in a section view, we saw two things: existing road and proposed road. And when we go for the material section, but we didn't do anything there. But when we go for the cut and fill criteria and set all the criteria there, then we can update the cut and fill also in a section view. So this is most important thing for the site engineers. So you have to give this cross section to the site engineers. So based on this cross section, they are working on the site. Okay. So first of all, you have to create a section view. Then you have to create a sample lines, and then they displayed these things. And now we go for the, see, when you go here in a section view, you can see create a section view from here. First of all, we select a sample line. Now we go for a section view. Also, if you come here, you can also set a section view from here also. If I select the section view 1, so I can create only section view for the one sample line. If I create a sample view for the multiple views, as I select, so this dialog box is open. Now understand this. We have alignment number 1. Okay, if you want to select if you have multiple alignment, you can pick it with the help of this tool. We have only one sample line right now, so it show us a sample line group name, sample line collection number 1. Now the range of station, you can select automatic, so it will take all the station. If you want particular station, you can click it here and you can select the station, any station from here. Okay, then I again click it in automatic. Then sample view name is I check the starting number is 1, that is okay for me. It will take the section views station 1 as a name. In a description you can set, and the view and style. This one you know already. Now the section placement. So what is the sheet you want to use to set this all the sections? They give you a sheet also, and also if you want to import your new sheet, as we are working in a metric, so I have to select this. If you have any template, particular template for the sheet view, you can select that template from here also. As I keep it what it is. Then if you want to draft section view in a grid model, like if you want to so this is the preview here. If you select this, you can draft all your section view here in a one set. But we go here for the production. So what happened in a production, we can create this in this sheet view style to make you understand properly. Then we go for the next offset range. You can click it from here also, and also you can set as a next. You can set this as we set it on in our profile view. The same profile view is there. So you can set your station offset range. So from the left side, from the right side, then the elevation range. So what elevation you want to do? Like if your maximum elevation is 58, so as I select automatic, it will take height of this section view based on my top elevation. But if I want to create, if I want to put it, user specified, I can select here and I can put it here. Then the next is display option. So here in the display option, you can see we have two things: surface and corridor. Grid view is there. Label set. If you want to set any label for the surface, you see EG section label, existing ground label, and set OK. If you want to set a corridor label, you can set a label like corridor OK. So this is the style. If you want to set the style, so now next is a band set. As in a profile view, we have a band, the same type. If I have a band, I take it as major, station, offset, and elevation. These three things. So if you want to put a band and whatever the thing, you have to select it from here only. So once you created this, you can edit, you can add the band also. But when this is working in a dynamic style, so if you select all the things during the process, then it will set properly. Now the band, where you locate the band, see bottom of the section view, it will show it here. In a bottom, your band is set. If you take it on a top view, your band is go on a top. But the bottom view is preferable, so I select it here. Now for the EG surface, our surface is for FG surface, I have to you have to change the surface here. We can edit it after this. Once we set all the things, you can create your section view by click here, create section view. As I select the create section view, you can see the identify a section view origin. So I have to click here on the screen somewhere. As I select here, it will take time, and see, it will create our section view. See, this is our old station 0, then the 20-meter of sample line, then 40-meter, every 20-meter of center line it will create. If I set that draft menu, then our all group is come in one sheet. Okay, but I choose this because you understand properly all the things. Now, is this is our cross section. You see here, you see our corridor. You check our corridor properly. See, so for this is our let's check it here on a 40-meter of chainage. See, you can check all the station chainage. See here on a 280-meter. See our sample line on 280-meter. See here our sample line on 280 meters. So I am checking this sample line. So what it do? This is the assembly. So it will take a cross section from here and show us this view. So how your corridor look like at this point, and where is the cutting and filling on this area. That's why I'm showing you this 280 meter of chainage. See again 280 meter of chainage here. Now you see there is a cut area here. See our road corridor, the one part is here on the top and the second part here in the bottom, and this is our surface line. See, if I click here, it will show us the existing ground. The white line is existing ground. If you change the style, the line color is changed. And this one is our, cut and fill. See, so this much is a cut at this section, and this much is a fill at this section. The bend that we set, you can see the bend here: existing elevation, proposed elevation, and offset. Now you can see the labels here. Now if I select this one cross section view, the same way, see, this is a section properties, this is a section view properties, this is a group view properties. If I change through this group view properties, all group automatically change. If I keep it for a one section view, only this section view will be changed. Okay, now let's go with the section properties. As I click, it will ask us select a section view. So as I select the section view here, as I select the section here, you can see the name and which style used, and the section detail, particular section detail. The change is this offset, which offset we take, what is the minimum and maximum elevation here. Okay, the ground is selected, type is selected. So all the description you can check it from here. If you go in a section view properties, so for this view properties, if you click it here, you can see the particular changes. You can see, you can modify it also, modify that section from here also. The elevation view, if you want to make the elevation more above, so you can select the user specified and put it the range from here 50 to 100. So the box is automatically adjust as per your elevation style. The section view style what we provided here, the ground surface and the corridor. So you see the two things here, the ground surface white line and the corridor. Then the bends is here. Now our first bend we select. You can set your you can also set your bend here, as we set our bend in a profile view. See, first of all we have a easy surface. Easy means ground surface. So so all the surface, we have a section, first section view. So it will select all the things automatically. You can save this bend set. You can save this all the bend, and if you want to use this file in another section view, you can import that bend also. Okay, right now we go in a volume table. So if you want to create the volume of rod, so you can create it from here, but right now we are not generating that volume dashboard, so we are not using this. Then profile grade line. So all these things we are check after this. I'm just showing you all the things proper in proper manner. Now if you change anything and if you want to update all the things here, you just select one section view and select update group layout. As you update the group layout, all the group is automatically updated. Now we want to add something after, like we have these two things and I want to add something. So I go here in a simple more source. See, I only have two things here. What I do, I create one new thing and add this here in a sample line. See, understand the workflow. See, as I escape, click on a escape button and close all the command. Now, what I do, I select my corridor and I generate the corridor surface. As we have a ground surface, as we have a corridor, but we don't have a corridor surface. So I click here on a corridor surface and click here in a first button in a surface. I click this button and then I give the name here. I give the name as design surface for corridor. Okay. Now, after selecting this, I want to see from the top. I want to see so I have to add the link. So I select the code, a top code here. Any of the code you can set from whatever you want to see your corridor. You can set that code here. I want to see from the top surface. I want to see from the top surface here. So I select this and click the plus button. So this top surface is added here in our design surface. Now I go here in a boundary. We have to select this boundary, because if we not select the boundary, what happen? This will take all area, the whole area. But if I set the boundary as I want to set my corridor surface till this boundary only, where my corridor is. So I select right click here and set corridor extent as outer boundary. There is another option. I want to set the boundary at whatever as per our requirement. But I set as the outer boundary. I select here and now boundary is set. Then I click apply and OK. Now your corridor surface is created. You can see your surface from point surface. See here in a surface. First we have only one surface, ground surface, name ABC. Now we have the second surface, design surface corridor. You can do any changes from here also. Is we create our surface here. See, you can see the boundary here also throughout the surface as I set outer boundary. Now what I do, I add this surface in our here in our section view. I select the section view and click on a more sample, more source. See, now our surface is here, which is not added in our sample cross section view. I select this and add here. As I add and click apply and OK. See, after doing this, I have to update the group layout. So once I do this group layout, so all the group automatically updated. It will take some time, but all your group is updated. Now see, you can see here. Now we have this existing ground profile. We have this top profile here. See, and then we have the cut and fill slope. Now because our starting chainage is on a flat terrain, we go here on the chainage of 280. Now you can see here all the things. See, the line, this line I select the first one. Second, you see this the top profile on the corridor surface, and the third your alignment. Okay, as you update, make sure that you must have to update the group layout. So as you update your group layout, your group will automatically update it. Now if I show here in a more source, I can see the three things are showing here. If I go in our section view group properties, you can see now you can see the three things is here. If I set the corridor one as a main style, so our corridor one grip is shown here in a surface style. So whatever the view you want to see, you can set it from here. So for the seat style that I use, See, once I use the while creating the section view, this is it. Now we cannot change this layout. Okay, so make sure that whatever the style you choose, choose it perfectly and then create the cross section. So the after work trouble is not there for you. So this is all for the cross section views. Now we have one more thing to show. Now we go for the quantity takeoff. Uh, how do we add or edit a retaining structure and cross drainage structure in Civil 3D? Same method. Everything here in a Civil 3D, once we imported it, in the same way you edit all these things, you can edit all the structures here. If you have any this retaining wall type of structure, you can import and edit it and do the practice so you can understand the workflow. Now just give me 2 minutes. I want to drink water until just give me 1 minute. So in a 1 minute, after 1 minute, we start our material quantity takeoff. Just give me 1 minute till just 1 minute. If you have work, just complete it. 939 exit 940. We start. Only 1 minute. Okay, now I hope my screen is visible and my audio is also you can listen properly. Please confirm once again so I go for the quantity takeoff.
Can you move the screen once and show, because its screen is still here now. Can you try to zoom, or can you please try to zoom the screen so that I can see that, because as I right, yeah, it's working. I think it's blur, but it's okay. Yeah, your screen is moving now. Thank you.
Okay, sir. See, so what I want to do, I go for the quantity takeoff first, and then I create the seed. So once you understand the whole workflow, and then we go for the seed creation and the data how you export from this view. Okay, so as we have less time, so let's start with the quantity takeoff. So as a quantity takeoff is used to calculate cut volume and fill volume. So this is directly related to project cost. See, it is a very important thing, quantity takeoff. Wherever you go for the interview, they will ask you, do you know the quantity takeoff? Do you know the earthwork calculation? So if you listen these two things, make sure, yes, you know these things. The earthwork calculation or the quantity takeoff is the same thing, as a quantity takeoff is a title name here in Civil 3D, and in the quantity takeoff we are going to calculate our earthwork. So the earthwork is used to calculate the cut and fill volume, and this is directly related to our project cost. See how important it is. So we use the section volume calculation and compare our existing surface with the corridor surface. So by comparing these two surface, now you know we have two surface. You see here in our tool space, in a surface we have a two surface. One is a name as ABC or existing surface, and the second one name as a design surface corridor is our corridor surface. Now, for example, if we have a cut volume of 5,000 meter cube and the fill volume of 3,000 meter cube, so now engineer have to decide that we have to extract extra soil disposal or we borrow the as per the area requirement. So based on this cut and fill volume data, engineer decide if we borrow new soil, or if we have to do the extra soil deposit. Okay, so accuracy of quantity depends on the three things. The first one is proper surface, the second one is proper corridor, and the third one is correct sampling interval. See, we created all these things, how the workflow connected with each other. We create a proper surface for the ground for as well corridor. We create a proper corridor, and we create a sample interval also. Now, see, here in a tool space, you have to go in a setting. As you go in a setting, here below, you see the quantity takeoff. See, if you click on a plus icon, they give three things: quantity takeoff criteria, label style, and commands. If I click here in a quantity takeoff criteria, already they give us the three things. But we are not take this whole thing directly. I will teach you how to create our criteria first, then how to give this fill this detail in that criteria, and how to create the reports. See, first you have to click here on a quantity takeoff criteria. Then right click here and start a new. As you start a new, you see here one dialog box named quantity takeoff criteria, new quantity takeoff criteria. See, this is the file name. So what I do, I set a new file name. First of all, I want to calculate the earthwork. So I set as our today day 5 earthwork. So I can pick instantly. Then we go here in a material list. See, kindly concentrate here. If you want to write down the things. This is the most important thing you have to set. Now we have to add two things: add a new material 1 and new material 2. As we have two things, the first material 1, I will give the name as a cut, and here in a material 2, I will give the name as a fill. See, FILL. Now here in a, see, this is our quantity type. So make sure the cut material have the cut quantity type and fill material have the fill quantity type. Okay. Now we select this cut quantity, and here we have to define the material. So the data type first, we define the surface here as a data type, and here in a surface we select the two surface. The first surface is ABC, as what is our ground level, and the second surface we keep it data type as a surface only, and here in a surface we select the second surface as a design surface, corridor surface, and click OK. See, now your both surfaces here in a cut view. The same I select here in a fill view. Again I keep it data type as a surface only, and then again I add two surface, the ground surface and the corridor surface. Understand? Now I want to calculate the earthwork. In earthwork, we calculate the cut and fill criteria. So I want to see how much cut is there, how much fill is there. Sorry. So for that, we have to make sure you play with this condition. If your ground surface is above, then you make sure your design surface is below the ground surface. So once this criteria, this condition is set, then only the cut criteria is worked. Because if you want to subtract, you want to do minus anything, you have to take this minus this. Then you a result that what we left after doing a minus. The same thing is the ABC is above. I select the ABC as below as our ground surface. So now all criteria is set here. Now I have to select apply and OK. So you can see here our day 5 earthwork criteria is set. Now I set the second criteria which I want to set for the material. See, we have 4 type of material here in a road cross section. I will show you. If I go here on a browser, I set like road surfaces types. See, I hope the screen is visible. See, I open this image, make you understand properly what we are doing. See, we set the material. So, as first we have the pave one here, the second DBW, the third WMM, and the last GSB. So we have this 1, 2, 3, and 4 layer here. So I set this 4 layer as a material. Okay, I hope you understand what I want to say to you. So we go here and we add 4 material, 1, 2, 3, and 4, and I give the name all the material. So let's give a name. The first one is a BC base course. The second name I provide is second number is DBM. While when you are working, you don't have to give this 1 and 2. But why I'm giving this? So you understand that we give this type of things. The third thing I have to give as a WMM. So this all are the layer name. And the fourth one I give as a GSB. Okay. So the same way I say it as BC. And the second DBM. Now, as we set a material, we have to set this quantity type. So make sure that material is come here in a structure. The cut fill criteria come here in earthwork, but material is come here in a structure. So we set this all as a structure first. Okay, now I have to select the first layer, and then I go here in a corridor shape, because in a corridor shape we have assembly. See, and in that assembly, we set our lane, and the lane have the different layer. So what I say, select the first here, set the data type is a corridor shape, and set the pave one, the first shape here. Then I go in a second type, then I set the data type same, and the pave 2 here, done. Then I go for the third, I set base layer here. Then I go for the fourth, and I go for the sub base date here. Okay, so I have 4 layer and I include that 4 corridor shape here. Now we all set, we go for the information, because still we are not giving the name. So we give the name here same as day 5 materials, and we select the apply and OK. See, our day 5 earthwork and day 5 material is there now. Now what we do, we go here in a analyze tab, and you can see the compute material tab is here. You click here on a compute material tab. As you click on a compute material tab, you see your selected alignment is road 1, as we have road 1 only, and the sample line is SL1, as we have only one sample line, and you select OK. As you select OK, now you have see compute materials dialog box is here. Now you have to select the takeoff criteria. I have to do the earthwork, so I create one design criteria here. So I select the day 5 earthwork criteria where what I created. Then in a surface, see, as a ABC surface, I have to select ABC surface, and for a design surface, I have to select the design surface, corridor surface. Okay, so these two things you have to fill as uh, as a material. So once you select this, then they will calculate this from this from this. Now we click OK. It will take some time, and now earthwork is done. We created the earthwork criteria, and we insert the material set. As we create the criteria, you see here in a cross section, filling and cutting already done. You can see the cutting part and filling part here. Okay. The second thing, the material. Again, we go here. The same process we do again. Now you see this type of pop-up box. The same. If you saw this, what you do? You click here, import another criteria. Is this one criteria is set material list? We set this material list. I want to import the second criteria, so import the another criteria. And what I have to import? Day 5 material that we created. I said OK. As I said OK, now we say here day 5 material is there. So whatever we create here is a day 5 material, it is here. Now we have to set this object name. We set 4 things: pave 1, pave 2, base and sub base. The same. So for pave 1 we set BC, we give the 4 names. See here, material name we already given, and the corridor shape is there. Now I just put that what is the BC as a pave 1. So I select the same name as a 1 BC, 1 number. The second number is there. Base, then pave, sorry, here in a pave 1 you select the pave 1, here pave 2 you select the pave 2, here in a base you select the base, and here in a sub base you select the sub base option. So you make sure that the same option you selected here, and then click OK, and then apply. See, your these two things is set now. You set apply and OK. It will take some time. Now all the things is done here. Now you see your cross section here. The cut fill is here. The material we put already, material is fill here. Cut and fill here. The ground profile is here. Corridor profile is here. So all the things are here. You can see all your offset and all that things now work properly. Even if you want to make sure that all the things are come or not, what you do, you select one cross section and update your group layout. As you update your group layout, it will update automatically in all profiles. See, this is our change number 40, and we set it here. So now, as again go in an analyze tab. Here we have a volume table, total volume table. If I want to create a volume table, I can select the volume table. As I select the volume table, you can see here cut and fill table style. A layer is there. Our road 1 is selected, our sample line selected, and the material list. Let's select the material list 2, then we select the material list 1 also. Then the tile of the tables, it is across the maximum row and the maximum table per task, and all these things you can modify thing also, or it will take automatically. Make sure your behavior is dynamic, and then click OK. As you click OK, it will ask you select the upper left corner. I will select any corner here. See, now you can see here. You can see all the data 0, 0, 0, 0, 0, 0. We don't have any material here. So what we do, we go again total volume table. We select a material list 2 here. Now we select the material list 1 and we set same and go again and we click here also. Now see, in a material list 1, our all material is shown here. Now you can see the table. I hope the table is visible. In a total volume table, you can see your all station, your fill area as per the station. At all station, you have your fill area, you have your cut area. What is your fill volume? What is your cut volume? And cumulative and cut and cumulative fill volume, you can show it here. See, till the end of the chainage. I hope you understand this thing. And if you want to give this thing, what you do, you have to select this. You can copy this thing by Control C. Okay, and you paste this thing in your Excel table or whatever, or you export this as an extendable in an Excel sheet. Now we go for the material volume table. As we already imported our material criteria, when we select here, as we select again all the things shown. Sample line 1, material list 1. For the material list 1 and 2, as I select material list 1 and now we click OK here. See, again I click here. See, your material table is here. So for each chainage, all the material data you can see here. All the volume of material what you use at each station. What is the area used, what is the volume used, and the cumulative volume totally they use. Again, you can select the volume table. If you want to set the material to, you can, if there is something in material 2, it will automatic, but we don't have anything in material 2, so nothing is there. So this thing we can delete, and the same thing for this thing is also deleted. So now we have this volume table and material table. I hope you understand till this. Then we have a volume report. See, when you click on the volume report, the alignment you have to give, the sample line you have to give, material list you have to give. If you have any particular sheet style, you can choose the template from here. If you want to display this as an XML report, if you click here and set as a OK, so the report is generated in a XML format. See, this type is a web browser. So I don't have this web browser in my computer. I close current tab. Let's see. See, because as your default browser is set, my default browser is set as this. So it automatically set here in a Google Chrome. But the second browser, if you have in Windows, it will happen. This browser is open anytime. So it is not an issue. You can close the browser. Now you see, whenever you give the volume report to the client, you can select this report from here. You can copy this report and you can give this report in a Excel file format. The thing I want to show you here is the cut, your all the station, the cut area, fill area. This is your fill area, cut area. This is your cumulative area. The last one is the net volume for and the fill volume and the cut volume. See this, compare these things. So as we manage all the things, if we take this much, fill this much of soil, we take this much of soil. So we don't have to take so many soil from the outside. So when you practice, when you create this table, you observe this table. If you don't understand this table, if you are not from this field, or you are not going through this field, what you do, you just take this all the detail and Google it. So they will give you all the definitions, what is this about, so you understand all the things properly. Now again I go here, in a toolbox tab. When you come in a toolbox in a report manager, whatever the report you want to create, if you want to create the point report, you go in a point list, and if you execute, then whatever the report you want, here you can click here, and the save, here I can save, I save here in your DA5 folder. See, as I save the all report generated here. See your point report, northing, easting, elevation, description. The same way, if you want to export any report, if you want to export your corridor, see the same way you can go for from this toolbox also. The next thing I want to show you is the sheet creation. I hope if 10 or 15 minutes will taken today, as this is our last day, no one has some issue today. As I have to finish this and want to show you all that things, so kindly keep patience for 5-10 minutes more for the today. So this is our last thing, then sheet creation. Then I will show you the last one is a super elevation, and then we finish the session.
Yeah. Do you think it will finish in 5 minutes? I think the list you said it will take more than 30 minutes, I think.
No, I will
Because
finish it in a maximum 10 to 15 minutes. Maximum.
all right.
Okay.
Okay.
See, now
Okay.
I want to create a sheet. So sheet creation means converting this design into the printable drawings. Okay. So you see here in output. See, we have to give this sheet to another one. We output our result. So click here in output tab. Three things you can see here. One is the create section sheet. As we have a section here, and if you want to create this section sheet, you can directly click here on a section sheet. Then the alignment is there, sample line is there, view group is there. You can layout, you can set the name, one starting number is 1, that's okay. Now we want to set a new sheet. As a new sheet, set 1, as I want to give the name as a day 5 sheet. If you have any existing sheet and you want to import this in that existing sheet, you can select this. You can select the location. If I want to select the location, and I want to set this here in your day 5 folder, I open this location set and I set as a create sheet here. To complete the process, you have to save this drawing. Yes, I want to save this drawing. So as I save this drawing, click OK. So all your section sheet is created. You can see we created almost 13 sheets. You can see this all sheet from here also. See here below. We are right now in a model tab. As I click on a layout 1, see your layout 1 sheet is selected. As I go for the layout 2, so this one is selected. But I go with the section view. As I select the section view 1, see we have to select the scale here. As I select this sheet, I double click here. Then you know what, you can set this all the things. See, you can see your profile. You can see your profile here. Your as we set all label set, so we have all the label set here. You can select this all the thing. double click here. Now here at bottom you can set your scale from the here, or you can unlock this sheet from here. Now this is whatever the cross section we generated, all the cross section sheet we created here. As we our layout is see going this is the grid view actually, so we can manage this from I will show you that also. If you want to set anything, you can see, if you want to give a project file name, you can click here, and you can set it from here, like day5. Okay, so this type you can put all the things here. You can export these things from as a PDF file also. If you set a PDF file, so all this sheet come in your folder as a PDF. The sheet, this is the sheet list, this is the sheet view, and this is the modes view. So once when you are working with the company, they have the proper template with the scale. So right now we have 1000 scale. As we set our scale below, so our sheet view is come perfectly. Then let's come again here in our model view. The next thing I want to show, then what if I want to export this our corridor and this our profile. So for that you first have to create a frame view. So when you click here on a view frame, then you create alignment number 1. Your alignment is here. The same thing as we created till that. The station range automatic, then we go for the sheets. So if I need a plan and profile, I can select the plan and profile. If I need only plan, only profile, I can select. So the template is very important. See, every time template is very important. So this time what I do, I take a A0 sheet which is scale till 5000, and I select OK. The next thing, view frame placement. You want along the alignment, or you want to rotate to the north. You can see the preview here. If I select rotate to the north, it will take like this. If I select the along the alignment, it will create a frame like this. Okay, set the first view frame before the start of the alignment. If you want any offset from the alignment, if I set this, so our first frame is from this distance. After this distance, they will create our first frame. But I don't want this option. Then I go next in a view frame group. So if you want to give the name, you can select the name. Starting number is 1. So this take VFG1. If you want to provide description, you can set it here. The layer and the sheet name is also here. I just check that the starting number is 1. Then the style you can set it from here, or you can edit this. The location, label location, you can set the label location at any. Then go for the next match lines. What is the match lines? Exactly, match line is one number below to the view frame. As you have a 5 view frame, the match line is 4. Match line is what? Between the 2 frame, there is a 1 match line. So you have a 10 frame, then you have a 9 match line. So there is also the layer, the name you can provide, set as 1. Okay. Style you can give. Start and end location, all the labels you can set here. You can edit the label from here. Then go for the next profile view. You can select the style of the profile view. Every company has their own templates. So once you import the template, there is no issue. You just click on that template only, your company template. So your all work is set with the set as per the scale. So band set, if you want to create the band set, you can select the band set from here. If you don't want any band set, you can say no. As I have the band set of day 4, I set the band set here. Then I select a create a view frames. As I create the view frames, Once I create the view frames, then see why this view frame is not selected, not created, as we have to set our screen like this. Then we create a view frame. As once we create a view frame, we go here in a create sheet section. Okay, then we go here in a setting tools. See, you can manage this view frame and sheet section from here also. You can set the label style from the view frame. You can set the view frame group also. You can set your all view frame sheet from here. You can edit your view frames from here also. You can edit all the things, like in a general you can set all the criteria, all that things you can set it from here. So as we have this section sheet, the same way we created the our view frame sheets. Let's again come in a model. Now the last thing I want to show you is a super elevation. As you select the super elevation, as you select the corridor, you can see one option in a launch pad, super elevation. See, as you create select the super elevation, there is a three things. You have to first calculate the super elevation, then you can check it from the view tabular form, and then you can create a super elevation view also. Once you create this super elevation, you can set your band here as a super elevation, and you can see the super elevation here also. So let's calculate the super elevation. Calculate the super elevation. The first we have to set is undivided crown. See, from the baseline we have two slopes. We have slope here also and slope here also. So I select this. If you have this type of this type of undivided planar, if you have this whatever the shape you have to select that shape. If you select this, in this you have to set these two things. I have undivided crown, so I select this crown from here. Then I set next button in a lens. See, in a symmetric roadway, what happen? If you have right side and left side, these two sides same. As we have 3 meter of length, so total length of our lane width is 6 meter. As you have the same lane width is here, you can select the symmetric view. If you uncheck this, you if you have a different slope here or different view here, you can uncheck it. But I have the same view, I can set is as a symmetric. Then whatever the lane slope, I have the 2% slope, it is okay now. Then next, then shoulder control. See, now the normal shoulder here it's they give, I will provide our slope as a 2, and I have the width as a 1. Then I set this criteria as per our assembly we created. The same thing, if we have left and right, we have set it also here, but we have both same. So I set this thing and then go for the next. If you as I select a symmetric view here, so I can control this only these things. If I set the view, if I uncheck this view, then in a shoulder control you can set this view also. Then next it is attainment. So here the with the help of which code you want to select the super elevation. Your as we have a 2-lane road, I select the 2-lane. If you want to set your own design criteria file, you can set it from here. See the what method it used for calculate the super elevation. So ASTO 2011 crown roadway method it used. So we apply the curve smoothing. I want the curve smoothing also, and I want automatic resolution. If there is something mismatch, it will resolve itself. Then I click on a finish button. As I click on a finish button, you show this panorama. It will show you all the things. See, if you want to manage this things, you go here in a super elevation and view tabular form, and select your alignment. Sorry, I select this alignment from here, so you can see it from here also. See, here you can see the curve 1, as we have a one curve, this one. In a curve 1, we have a run out, run off, and for a transition out region, we have a run out and run off. See, as I click here, our station and our length of this our transition length, it will show. Then all the things, because we select, if there is some mismatch, you can manage. So they and we provide all the details of our shoulder detail, our slope detail, so there is no error here. As we set a design set criteria as ASTO 2011, even there is no error you are showing here. So as this one is all set, then you can go for click OK. If you have something problem here, you can if you have problem here in a course smoothing or whatever, you can change your length. As you change your length, your smoothing is changed. If there is a yellow mark here, you can set it by trial and error method. As I click OK, my super elevation is created on this part. Now I want to show how my super elevation created. We go here in a create super elevation view. I select the alignment from here. Then again, we have to set the super elevation name. Then the road 1 alignment. Then the super elevation view. The station, I choose this, all the station, I want this throughout the alignment. Then if you don't want any shoulder, you can uncheck the shoulder. If you want the shoulder, you can check the shoulder. Right now I will show you for the lane only. So if I set OK, it will ask me select the location at anywhere for the origin point. As I select the origin point here, you can see your super elevation table is created. So this is your elevation percentage. This is your chainage below. This all is your chainage for the curve. For this particular curve, it will show you from this from here to here for this curve only. So from this curve starting to end, you will show your super elevation view. See, this is your end of curve. Then see, you can see your slope -2%. As our transition length is start with the slope of -2%. Then they go ahead, and from here it will take a curve. So this is your baseline, and it will take a curve. In a curve, you have the slope as a 4%, super elevation is a 4%. Generally, as per theory, it will take till 6%, but in a practical, we will take till the 4% only. 3 to 4% is manageable. Then again, the curve join with our existing alignment, and 2% is slope is there. If you want to add this super elevation here in your profile, you can select your profile here, and in this profile view, you can go here in a profile view properties, and in properties you can we have a data set. You can set your super elevation, select the super elevation, and we have this divided with 2 crown, no shoulder. So we select that no shoulder super elevation, so we add this, apply, and OK. So as you select the super elevation, bar is there. Now for make visible this super elevation, if you select the wrong thing, then your super elevation with no shown. So make sure that whatever the crown you use, You have to select it properly. See, this also is not my crown. Okay, apply. Okay, so as you set your super elevation, it will show here. uh because I don't concentrate on my crown part, so super elevation is not shown here. But when you practice, you make sure that your crown part is whatever the crown part you selected from the first till the end, you have to select the same, so this work properly. So this is the one way. If a client wants that I want my super elevation here in my profile view, then you can generate a as per your bend style. But mostly we give our super elevation detail in this form only. Okay, so this is the thing I want to clear you. So till that we created the whole complete road design workflow from road survey data to sorry 3D road model, then cross section, drawings and quantity. So this is exactly what is done in the highway projects, infrastructure project, and international projects like Dubai, USA, and UK, Australia. So if you understand this today's concept clearly, you are already, you know, able to join a junior design engineer post. So only one thing is missing, that is the practice. So as you practice the much, you can deal very much better with the software as well the design. So today is our last day. So I hope I cover all the criteria, because Civil 3D is a vast software. In each tab there is a lots of tools, so it is impossible to cover all that things. But I cover your mostly area which is used to work in the infrastructure design project. So again, the workflow is very important. Whatever the workflow we go through day 1 to day 5, you have to remember the workflow and you have to practice as per that workflow. And before closing the session, I want to make you mark your attention, as we have so many students that is new here in our session. So I want to show them what is the exact super elevation. See, if I see my road in a 3D view, and you set it as a 2D wireframe, the design view set. So your elevation is started from here, from the transition length, and then it go here. So what is we have to manage? The outer edge of the road and inner edge of the road. We have to keep the outer edge upper than the inner edge. So that's why the forces that force our vehicle to go outward of the road, so it will manageable, it will manage the force, centrifugal force. So this is the slope that created here in a super elevation. This is the type of super elevation. When you read the super elevation theory, you can go through this all crown parts. This is the normal crown you can see in a in this shape. When our shape is changing from this to this, it will called our level crown, and in this shape it will shown as our full super elevation. See, we see two things while created the super elevation: run off and run out. So this area we called as the run off area, and this one is run out area. So when we go from this to this to this, our run off and run out area change. As I told you, if there is a you're shown any mistakes in slope or anything, as I told you that you have to manage your length. As you manage your length, your slope will be better. So this is your super elevation, and how it look like on a real road. When there is a sharp curve, we have to provide a super elevation. See here, when our vehicle is on a speed, then a centrifugal force and the outward force, these two forces are acting on our vehicle. To resist this force, we have to provide the super elevation. This is the simple definition of this super elevation work. So once you work, you go through the theory as well. You practice this here in our Civil 3D also. You check all these things, how your curve create. You give the label here. You check your radius. Then in ASTO there is equations for creating the calculate the super elevation. For that you need f value, you need the length, you need slope value, and design speed. So with the help of this four thing, you can calculate your super elevation manually too. So this is it. This is it for today's session. If you have any doubt after this session, you can ask me freely. I know you all have the busy schedule. Some of you are working professional. You are busy throughout the day. Whenever you start your practice and you have a doubt, you can take a screenshot or you can take a photo and share me and ask me the question. And in 3 or 4 days or in a week, you practice these full things at your own and send your file to me with your name, so I can check properly you understand it or not. And then after we will provide you the certificates. So once again, I am taking your leave, and at last I will show you my face. So in future, if you met me, you know me that I am Dr. Abrar Khalak. So I hope you understand and you enjoy the session. So I wish if you are listening me, you open your camera, and then we conclude. We close the session. So if you not have any restriction, you can open the camera. Don't worry about it. I will not take any screenshot. So I hope you are not going to open your camera. Don't worry about it. So whenever you want, you need my help, you can reach me through the WhatsApp or through the LinkedIn. I am also available on the LinkedIn. I am very actively available. I don't use Instagram and that type of thing, so you can contact me on LinkedIn, or as well you have my WhatsApp number. I have a page on ResearchGate also. I am actively doing research too. So if you need any help in research, you can also contact me for software related issue, or you want to grow better in the BIM workflow. You can contact the Shivam sir too. He will also make your all the doubt clear regarding this Civil 3D software. Now the important part is sub-assembly, composer, and then Dynamo is there for automation work. Then infra work is there. Again, Navis work is there, which is very important. So when you work in a company and you got experience, so you have to face this all the softwares: AutoCAD, Civil 3D, infra work, and Navis work. So this is the basic work. So you can work as a junior design engineer, assistant highway engineer, Civil 3D draftsman. So this will be your job position. If you have an interview, if you need any help, you can contact us. If you want to create your portfolio for the job, you can also contact us. So I will take your leave. Bye bye everyone. Khuda Hafiz with our slogan, sharing is caring. I hope if you are experienced or if you are starting your career in this field, you can remember my motto, sharing is caring. Make sure you always help the people who are surviving, who need help. Make sure you need help them, and you wise your expand your experience wisely. So that's it from my side. Thank you, Shivam sir. I am taking the leave for the today's session. Thank you all of you. Thank you.
Thank you, Alka.
Okay.
Thank you.
Yeah, already sharing group feedback form, so you can take feedback. Okay.
Actually, successfully